4.1 Exponential functions. Functions whose equations contain a variable in the exponent are called exponential functions. So we have not dealt with a variable in the exponent. And we have many real-life situations which include population growth, growth of epidemics, radioactive decay, and other changes that involve rapid increase or decrease can be described using exponential functions. So we're going to deal with some of those in this chapter. So again, an exponential function has an equation, and then the variable has a variable in the exponent. Okay, so the definition of an exponential function with base b is defined by f of x equals b to the x or y equals b to the x. B must be a positive constant, so this base has to be a positive number other than 1, and x is the real number. The exponent must be a real number. Some examples of exponential functions are f of x equals 2 to the x. Rewrite that. F of x equals 2 to the x. G of x equals 10 to the x. H of x equals 3 to the x plus 1. And J of x equals 1/2 x to minus 1 power. So notice how all these bases are positive. They're all positive values, and they're not 1. So as long as it's positive and it doesn't have the value of 1, and then every exponent has a variable in it. Okay? Some examples that are not exponential functions would be something like f of x equals -1 to the x power, or g of x equals x squared. Here we have a base other than 1, or other than a positive number. This is the negative numbers. We don't have that. And then we do have an exponent, a variable in the exponent. But again, we need to have a positive base other than 1. This right here, there's no variable in the exponent. This is something we've dealt with in previous chapters, x squared. The exponent does not have a variable. Okay. Let's talk about example 1, how to evaluate an exponential function. The exponential function f of x equals 42.2 times 1.56 to the x power. This amount is the average amount spent in dollars at a shopping mall after X hours. What is the average amount spent to the nearest dollar after 4 hours? We're going to go ahead and put input 4 for X. And I got to put 4 in for X. Let's type in the calculator. You should get approximately, and round to the nearest cent because money, we're round to the nearest cent, $249.93. Okay, so in your calculator you can type in 42.2 times 1.56 raised, and the raise button is right, that little caret button, to the 4th power. Again, if you have the calculator I told you all to buy, the TI 30X2S, you should be able to type this all in one step. Now if you bought a different calculator, you might have to do this first and then times it by this. So again, just play around with the calculator, make sure you know how to use your calculator, and you should get that answer. Okay, so the average amount spent in 4 hours is approximately $249. Oh, near dollar. Oh, we wanted to near dollars, so I'm going to go ahead and round it off to $250. Normally I want near a cent, but they went to nearest dollar. Okay, so go ahead and pause the video, and on your own, find the average amount spent to the nearest dollar after 3 hours at the shopping mall. And this is really just for you to get familiar with your calculator. So go ahead and pause the video, and then I'll go ahead and put the answer up. Okay, so I did f of 3, and I got approximately $160.21. And when I round up to near a dollar, the average amount spent in 3 hours is approximately $160. Okay? If you have any questions about your calculator, make sure you let me know, and we can try to deal with that before the next exam. Okay? Let's go to example 2, and how do we graph an exponential function? What I'm going to do right here is I'm going to actually make a table, and I think by the end of this chapter, some of y'all can just make a graph without a table. We do get those used to the values that you're going to see. Let's go ahead and make a table with the x value. We have f of x equals 2 to the x power. And then we have our x comma f of x, or f comma, or x comma y. Okay. When I pick the value of 0, f of 0 equals 2 to the 0 power. Remember, 2 to any, or 0, 2 to the 0 power is going to be 1. So I get 0, 1. Put 1 there, I get f of 1 equals 2 to the first power, which is 2. So I get 1, 2. Do a 2 there. Get 2, 4. And do a 3. And if you do a 4, you get 16. So the numbers get really large. The y values will get really large there. Now what if I did the negative values? So if I did negative 1, hit 3, 8. The negative 1, this would be f of negative 1 is going to equal 2 to the negative 1 power. Remember the same thing as 1 over 2 to the first power. We have a negative exponent. We can make the exponent positive by moving the base down to the denominator. That gives me 1 half. So negative 1 comma 1 half. But in negative 2, I get 2 to the negative 2 power, which is 1 over 2 squared. That's back in the P chapter, talking about the negative exponents. I get 1 over 4. If I did negative 3, I get f of negative 3 equals 2 to the negative 3, which is 1 over 2 cubed, which is 1 over 8. And likewise, I'm not going to keep on going, but what if I had like negative 100? What would that really be? It'd be 2 to the negative 100, which is 1 over 2 to the 100 power, which is a very small number. It's going to be one large number down here. Then you might have noticed that this number got smaller. 1 half, 1/4 is smaller, 1/8 is smaller. If I have 1 over a trillion, whatever this number is, 1 over that's going to be super small. So I end up getting a very small number. No matter what I put here, if I did negative 1,000, negative million, and so on, I'm always going to have 1 over some number. I'm never going to have it equal 0. Okay. So let's talk about how to graph this. So let's go ahead and look at our points. And 0, 1, which is right here. 1, 2, 2, 4, 3, 8, right there. And then negative 1.5 would be right here. Zoom in a little bit. I have negative 2 and a 4. Negative 3 and an 8. And you can see that if I did the negative 100, it would be way down here, but it would be a very small number. It would still be more than 0. And so we're going to see we're never going to have that y value be 0. So we're going to draw a little asymptote like we did in the last section, the last chapter. Y is never going to equal 0. So we have a horizontal asymptote. Y equals 0. So we know it's never going to reach 0. And that's why we draw that there, because we know this graph going to go forever in both directions. This number, this graph is going forever here. It's going to be a very, very small number for y, but never reach 0. And then this is going to increase sharply that way. Okay. So again, a lot of students will do this table in their head. They'll put the exponents in their head. They'll come up with these points pretty quickly. And then here, they'll get the little fraction, and they'll start to realize that it's going to reach an asymptote, a horizontal asymptote. Okay. So go ahead and pause the video. On your own, go ahead and graph f of x equals 3 to the x power. And then we'll go ahead and restart the video and check your answer. So here's what my graph looks like when I did the problem on your own. And my table, I picked values for x. I did 0, 1, 2, 3. And some of the numbers, this was too large for me to graph. I got 0, 1, which is right there, 1, 3, 2, 9. And then for my negative x values, I got very small y values. They kept getting smaller. Okay. I drew my horizontal asymptote because I'm only going to have 1 over some number, no matter what this is right here. And so it'll never reach 0 there. Okay. Let's go ahead and do example 3. Let's graph this exponential function. And so I'm going to graph g of x equals 1/2 to the x power. let's recall that 2 to the negative 1 equals 1 over 2 to the 1, which is equal to 1 half. So what I can do is I can replace, since I know this is equal to 1 half, I can replace this with 2 to the negative x. I know that 1 half equals 2 to the negative x, or I can replace this with 2 to the negative 1, because I know 1 half is the same thing as 2 to the negative 1. I replace it with this. So g of x equals 2 to the negative 1 times x, which is the same thing, or not times x to the x power, which is 2 to the negative x. Okay. It's a little bit easier for me to do it this way than, especially if I don't have a calculator. I'm going to make a table. G of x. Zero, 1, 2, 3, to negative 1, negative 2, negative 3. Okay, 2 to the negative 1, which is 1 over 2, 1, which equals 1 half. So I get 1 and 1 half. To the negative 1. So if I have g to the negative 1, that's going to give me 2 to the negative of a negative 1, which gives me 2 to the 1, which is 2. The negative 1 will be 2. And if I do negative 3, I get negative 3, 8. Okay, so let's go ahead and plot these points. I get 0, 1, 1 and a half, 2 and a fourth, 3 and 1/8. So I can get smaller this way. Negative 1, 2, negative 2, 4, negative 3, 8. Let me redraw that. Okay. You know this number right here, no matter what number you pick, 1, 2, 3, 4, 5, 6, this number can get smaller and smaller and smaller. That's why this never reaches 0. The y never reaches 0 here. I'm going to draw an asymptote here. Horizontal asymptote is y equals 0. And I haven't done this yet, but let's go ahead and do it for the previous problems. The domain of this problem, what can x be? X can be any real number. From negative infinity to infinity, because I can pick x to be whatever I want. It's going to give me a value for y. Now the range, the y value, the lowest it can be is really, it's going to be 0 but not ever reach 0. So it can get close and close and get smaller and smaller and smaller and smaller and smaller and smaller, but never reach 0. So I'm going to have 0 as my endpoint but not include it. I'll go to infinity. Okay. We do last few examples. The domain range going to be the same here. The domain is going to be all real numbers, and the range is going to be from 0 to infinity. And same here. So go ahead, and the next example, I want you to go ahead and do this on your own. And they tell you you're going to do 1/3 to the x power, and then you're going to note that 1/3 they make 3 to the negative 1. That's going to help you make your table. Notice I'm not using my calculator in any problems. So go ahead and pause the video, and then you restart it and check your answer. Okay, so here's my answer to the on your own problem. Check your points. And one thing I want to note is if you don't make a table, which is fine, some of y'all can do this in your head, make sure you label your points. So if you label your points on the graph or label them in the table, one or the other, you don't have to do both. Just saves you a little bit of time there. Okay, this is the end of this 15-minute segment. So we're going to go start on next page, the next segment, and we'll finish the section up in part 2. Hopefully part 2 or 3.